Hi viewers and welcome to the channel and welcome to another lesson of the Understanding FreeCAD series. This is lesson 3. In this lesson we're going to be looking at creating a piston head, controlling arm and crankshaft, and then we're going to be taking those and connecting them together in an assembly, simulating them and animating them so we can see them working together. Now from lesson 2 we learned about master sketches. We're going to be using those again in this workflow and later on the A2Plus assembly workbenches to put these all together to simulate the movement of the piston and the crankshaft as though it was in an engine. So in video 1 we're looking at creating the master sketch. Now the master sketch will contain a very simplified version of the piston head, the connecting rod and the crankshaft at its lowest position, so all connected together. In the same video we'll learn how to create a piston head using revolves, using datum planes and learning how to position grooves and holes in that piston head so they line up with the rest of the assembly. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. So in FreeCAD, we need to open up a new document and jump over to the sketcher, because what we're going to do is rough out some guidelines of where we're going to start sketching the piston head, the connection rod and also the crankshaft, and how it's going to be connected to the spinning axle or the point of rotation. So let's create a new sketch and look at it along the ZX plane. Okay, so the first thing we're going to look at is the piston head. Now if we think of where the piston head sits, if we look at it straight on and draw a border around it, then it's basically a square, like so. As simple as that. And we can give this square some dimensions. So I want the top of the piston head to be around about 80 millimeters wide and the height something like 60 millimeters high. So you're looking at basically a square around that. As a matter of fact, let's go a bit higher. So something like 100 mil in height. So we've got that square or rectangle there. We can position this. I'm going to make this positioned center across here. So I've selected this point, and I'm going to make it symmetry to the center point. So the ones on the corner, and last of all the one that I want to make it symmetrical to, and use the symmetry constraint, and that's constrained it there. Now we've got that, we need to create an arc to allow the crankshaft to sit inside the piston, saving space when this is at full retraction. So when our crankshaft has moved, it's pulled the piston down, then it needs to be embedded in here. So we've got to cut some space out. For that, I'm going to sketch the crankshaft to get an idea of how that's positioned there. That's just going to be a circle. So we're looking at simple shapes to start with. So just place a circle on here. And you can see, and when I create the circle, we can get an idea of how and where that's going to sit. So I'm just going to bring this circle down. Remember, I'm not dealing with measurements I've got written down on a piece of paper. I'm just doing this by eye at the moment. Just get an idea of where this should sit. So I'm going to click on the circle and click on this point and put them as a fixer point on an object. We don't have to do the other side because that's already fixed. So when I increase and decrease this diameter, you can see how that sits. And I'm thinking something like that. So I'm going to fix the radius of this, or we can go diameter. 198, I'm going to go for 200 millimeters on the radius and place that over there, sorry, on the diameter. If you've got too much lineage or too much on here, we can go for a radius instead of 100 millimeters, and that will mean that we've got less on screen to deal with. See, we've got a smaller line there. That's a radius of 100 millimeters. I'm going to place a line across here. I'm going to connect it to this side. I've got the auto constraints on, I've got the avoid redundant auto constraints on as well. So I'm going to create a line going across here. Make sure we get the horizontal and do the same on the other side. We know that each of these lines is going to be the same as the radius. That's connected there, so it's gone green, auto constraint. The reason being is I'm going to create a circle down here to get an idea of how this crankshaft should look. So we're going to create that circle now. Place a circle in here. And this is where this piston will be connected to a control arm, and it will be connected to this circle here somehow. So we've got the circle there, and what I'm going to do is take this circle and this line and create a tangency constraint between there, so it sits on that line. Then I can adjust this to how I see fit. Let's bring this up and recentered. And I could take a radius of this or a diameter. I'm going to go for a diameter, so I'm going to go about there. So it's actually within this circle, makes it nice and neat. Let's go for diameter. It's 99, let's go 100. So there's 100 millimeters there. We know that's 100 millimeters going this way. We need the rotation point, which will be about here, so 50 millimeters up. We'll do that in a minute, but we're carrying on with this here. I'm going to create an arc between this point and the center point on here. So to do that, if we come in, we'll first see the center and end point arc here when we very first come into the sketcher. Just drop this down, go to endpoints and rim point. And I'm going to place a point on here, connect the point up to here, and now we get the arc, and I can just go up and make sure my mouse pointer goes over that center line, so we get the tangent constraint by the side of it. You can see it popping up there. That makes that tangent there, and what should happen is this point and this point, put a horizontal constraint in there, that should line up nicely like so. And we can do the same on the other side. We could, for instance, we could take this, rather than doing it again, we could take this and control click the center line, and that will mirror this across when we use the mirror tool, or we could just redo this on the other side. The trouble is that if you do that, then it's not going to be attached anywhere, so we need to attach the point to that point, make a coincidence, and this point on this line, and a point on object constraint, and then make this curve and this line tangent with each other. You can see we've got some endpoint to endpoint tangency was applied, the coincidence constraint was deleted, which is good because we've got the auto remove redundance on. And then we can look at making sure that this point and this point are in line to make sure we've got the fully constrained sketch there. So you look at this shape, this is the shape of the crankshaft that we want. We also need to set the center point along here somewhere for the center of rotation for the crankshaft. It's going to be about here, which is going to be obviously 50 millimeters up because this is a 100 millimeters radius. So I'm going to create a circle on here. Don't have to worry about the size of the circle. It's just an idea of where to place another circle for the actual axle or the rotation point. I'm going to set some radius on here, so I'm going to say around about that, and do some diameter on there. So 59, let's go for 50, and make sure this is from that center point to here, it is 50 millimeters away. So that's our rotation point. This piston is currently, well, the sketch of the piston means it's currently at the full down position. So our piston rod, or our connecting rod, will connect from here to here. So we need a line in there. Place a line between those two. and connect up. And that's gone green, so that's fully constrained. It may be a bit hard to see what's happening. Let's put a height in there. It's 191 millimeters, that height there. It's going to go into redundant constraints here because there's too many constraints in there, but that's fine. Let's just get an idea of where that line sits, but we'll be able to pull that line in. So what we've done is basically created a sketch from the profile of our piston. May look very rough, but we can use this as something called a master sketch, and we're going to be using that to understand where we're going to place all our items and constrain them to here. I'm not too happy with the height, so I'm going to do some amendments to make that something like 90 mil. And just having a look, that's good. So I'm going to close that, and we now got, look at this, we've got the basic profile of all the pieces connected together. We're going to be using this as a master sketch, so we're going to be using a master sketch workflow to do this. So our sketch sits here. I'm going to rename this to master sketch. So this is the piston. This all of here is the crankshaft, and this line here will be the connecting rod. We've also got to come in and have a look at, well, we've got to place a pin through here. So let's place a circle here and connect it out to that center, and put some diameter on here. That's 31 at the moment. Don't want it that big, I want it something like 10 mil. Maybe a bit too small, say 25. So this is the beauty of having a master sketch. We can actually play with the dimensions. So 20 mil for a pin does seem a bit big, but we'll go for that for the time being. Let's close that. Got the pin that goes through there. Got this line here, which is the connecting rod. I may move this pin down a bit so I can come in. So let's delete this radius. Matter of fact, I'm going to delete the whole circle, and I'm looking along this line and thinking to myself, I'm going to actually delete the line, click on the line, and create the circle that's coming around about here. So this is going to be the connection to the connection rod, and set that diameter to be 15 millimeters there. It's better. And now I can set some height on here. 22, let's go for 20 mil. And the rod, now we can place a line that connects here down to this point here. That's our line that goes in here. So if I close that, we can see there's a connection rod. There's where the pin will sit to connect the connection rod to the pin. There's the center of rotation. So when this rotates up, this piston will be at the full height. And when it rotates back down to where it is here, we can see that will sit in here. Now we've got the master sketch in here. We're going to create separate bodies for each of these parts. But the trouble is we won't be able to get to the master sketch without creating a clone. So we've got our master sketch sitting here. Let's come over to the part design workbench and just create a body in here. First of all, making sure we haven't got the master sketch selected, and create the body. That creates a body in there. We can use that against our master sketch to create the body that we want. First thing I'm going to do is clone this master sketch into this body. So I can come over to the draft workbench. There is a number of ways of doing this, but we're going to be using the draft workbench. We can click on the master sketch and come into the clone tool here, the sheet tool, or modifications, and clone. That clones that master sketch there. So any amendments made to that master sketch will be made to this clone. I'm going to drag and drop this into the body. So that's inside the body now. That means when we create a sketch in here, we've got access to the master sketch. Make sure our gridding is off, so if it's on, if we come over to the lock icon there, you see this gridding here. If that's on, draft grid, then just turn it off. Let's come back to the part design. And now we can create our sketch. Make sure the body is selected and create the sketch. And we're looking to create the sketch along the ZX plane and hit OK. Now I'm going to import this geometry here. And if we come in, open up the body, we can see our master sketch is sitting there, but we won't be able to import this geometry just yet. So if I click on create an edge link to external geometry and try to import that, if you look down to the bottom left, it says object belongs to another body, can't link. I'm just going to hit escape to get the mouse pointer back, because what I need to do is click on this master sketch here, press the space bar to hide it. Because what's actually happening is that the geometry is taking the topmost item, which is this master sketch, which sits on top of our clone. If we try this now by using the same tool, also available from Sketch Geometries, External Geometry, we can see we can start referencing this. Now I want to create a revolve of this object here, and we're going to import these vertices here and this one down here, like so. If you can't get to the vertices, what you can do is come over to the master sketch, come out to the view and look down to the point size. At the moment it's set to 4. We can increase this up. This means when we use the create an edge link to external geometry, it's much easier to get hold of those points. I'm just going to hit escape because I don't want that. Just going to click front so it's nice and square, and we're going to come in and I'm going to start sketching. So I'm going to sketch a revolve. Now for a revolve we need a closed sketch. So I can place a square in here and revolve it. No problems, that's a closed sketch. But we need the 3 voids, the 3 grooves that run around here for the separate piston rings. So we've got a number of sealant rings, we've got a wiper ring and an oar ring that goes around here, and they're all connected into a groove that goes along here. So I'm going to create these grooves. So I'm going to use the create a polyline, and we're going to start sketching from the center. So we only need one side because it's going to revolve right the way around this line here, and we can connect up to here. See, it's gone green, and we're going to use this line. Now I could import this line if I so desire. As a matter of fact, I'm going to do that. Let's hit escape again, and let's import this line as well. This makes life a lot easier, because what I can do is use the polyline tool, connect to that point, and use this line like so, and create a number of grooves. Connect to the line, connect to this line again, and next groove, and last one. And all we need to do is move this up, and to connect to this point, connect to this center line, and we need to close this sketch. So I'm just going to move up to the top and close that sketch like so. Let's make this fully constrained now. So we're going to look at all these. Now I know with the piston one of the grooves is slightly bigger. I think that's for the wiper ring, but we're going to just keep them all the same size. So I'm going to click all of these lines. Matter of fact, I can click this line as well. Just work my way down. So the last 2, and create an equality constraint across those. So those are all equal. So if that moves, you can see they are all equal now. And we can place some length in here, 5mm. That'll do us. And I'm going to set this one something like 10mm, and you can see that's constrained down now. Got hardly any constraints in there, hardly any datum constraints in there. We've used the master sketch to constrain this down, and that's perfect. So that can be made as a revolve now. To come out of here, so come over to task, click close, and what we're going to do is just going to zoom in, and we're just going to hide this master sketch for the time being so we can see what we've got. We've got this now. Click on that sketch and we use the revolve for selected sketch, or come up to part design, create an additive feature and revolve. That revolves that around the axis. If it doesn't revolve it around the axis, just pick the middle axis there, and it says axis base Z axis 360 and hit OK. So that's revolved that top. Now what we're going to need to do is create a void inside here. So we're going to click on the bottom and create a sketch in here. So that's attach that sketch to there. So we'll see a new sketch that's sitting here, and we'll come up to data. We can see the map mode is flat face, support is a revolution, face 15, which is this bottom face. You can see, we can't see at the moment if I was out of this sketch. Let's close that and hover over that bottom face. You can see that's face 15. Let's go back in that sketch. I'm going to create a circle in here, and this is just to remove material. So we're basically removing material from in here, and hit escape. I'm going to set some diameter on here, 68. Let's go for 70. Okay, that. And there's the diameter of that. Close that, and we're going to use the pocket or part design, create a subtractive feature and pocket that. We're going to set that. Let's come in and do about 20 mil. See what we get there. Let's go further. I've forgotten what height this is now. Let's go 60 mil. So 50 millimeters there. So I've got that pocket in there. That's okay. That. So I've got 50 millimeter pocket, and now we need to create the hole in here. So if I bring back the master sketch and have a look, see what we've got. We look inside, we can see that, well, we need to create this hole, and also we need to create this curve shape that goes in here. I'm going to create the curve shape first. So to do that, I need to attach a sketch onto here somehow. But we've got curves and this straight edge here, but I want to attach a sketch basically in the center and then pad out from that. So we're going to need a datum plane. So a datum plane will allow us to create a new plane that's attached to the object, because we can't attach a sketch to this because it's a curved surface. But datum plane will allow us to do it. So I'm going to select the bottom face and click datum plane on there, and I want to flip this around. So I'm going to come over to the datum plane options, scroll down and rotate around the x-axis. Let's do 90 degrees around there. Click, and that's perfect. Now where does this connection rod need to sit? So it's going to be flat going in here, so the hole to the connection rod is there, so that is correct. So that's going to be sitting there. So our curve comes in here with the crankshaft, like so. So that curve will be removed from the bottom there. That's good. So I've worked out that's correct. We may need to use the flip side to flip the sketch around the right place, but that should be fine because we can put a sketch in either side of this. It's in the middle anyway, so that's okay. That's sitting there, that datum plane sitting there. So click on the datum plane, click on the sketch. So that sketch has been added to that datum plane. Let's use the when in edit mode, switch between section view. That cuts that in half, so we can start sketching on here. So we've got our sketch and we're ready to start pulling in some geometry. Now what I'm going to have to be careful of is to make sure that I go beyond these points so I can actually section this out. I'm just going to test this by placing a square around here, like so. Hit close, So you can see how this will sit in here, and we're going to use a pocket with this, and what we'll do is do a symmetry to plane and go through all, and that will pocket that out. So that's what we're looking to do, but with a curved surface. So we'll cancel that and come into that sketch, and let's just delete this out. Let's go section view again, and the datum plane is sitting there, so that's fine, that's all fine. Let's get rid of this and come in and make sure our master sketch is visible. And this curvature I'm looking at here, so I'm going to import that curvature. So we want something that supports this curvature. So this is what we're looking at removing from here. So we're going to follow this closely. I want to be a bit above here, and I want to be in line with this line as well, or just beyond it. So now I've got those, what I'm going to do is come in and create a curve that comes out of here. So we're going to first create a line that connects this arc just below this line here, so that connects those. So we're going to be removing material at this point. That makes sure we get this end line here. Going to also create an arc in here. So I'm looking at this and thinking, well, I'm going to need a point above here. So I'm going to use the point and place the point just above. And I can modify this point. I'm going to hit escape to get my mouse pointer back and click on this point and use the height. So it's 18 millimeters at the moment, so that's good. So that's just above there. And I'm going to add a line in here, like so. And the same on this side, another line in here. Hit escape, and I'm going to use the 3-point arc to this point, and come up and connect to that point there. So now we can adjust this to follow this line. So I'm going to come down, make these two equal, using the equality constraint against those, and now I can adjust those to how I see fit. Once I've got them to what I want, then I can come in and set the height. So 2.5 mil. Also can set the width. That's fine. And now I've created that shape there. So that's what I'm going to remove from here. I can do some finer adjustments if I so desire. So for instance, I can take this up and make this 17.5. Got a bit more gap in there, and that's good. I'm quite happy with that. So now I can zoom out, come up to task, hit close, and I'm going to hide that datum plane and hide the master sketch. So click on the sketch, click the pocket. This pocket's in there, make sure it's symmetrical to plane, so that's running straight for that middle now. So you can see when you change that, what happens. Let's bring this down, click on bottom. So that's symmetrical to plane. Okay, and do through all. So that will clear all of that out and create that curvature there. So nice curvature there. Hit OK. And now we can place the hole in here. So again, bring back the master sketch. So you can see how useful this master sketch is. To create the hole, I'm going to have to create another datum plane in here. I can't reuse this one because it's attached to that pocket face, but now we've got a different face in here because we've created a different pocket. So there's a number of ways to do this. Some ways may not work with the assembly. So I'm going to do this one way. If we have a problem, I'm going to come back to this and readjust that pocket for the hole and create it a different way. So to do that, I'm going to click on this pocket here, that pocket face, and create a datum plane again, also available from part design. Create a datum, creates a datum plane, places a datum plane there. We're going to flip this around along the x-axis, or the z at the x-axis, around x, 90 degrees, and that should flip it around that way. That's not where we want the hole. We don't want the hole that way. We can see the hole there. So we're going to have to go x around the z axis, 90 degrees around there as well. Places it in the right position. Okay, that. So now we've got that datum plane in there. We've got the master sketch. We're going to utilize that circle here on the master sketch. So we can click on the datum plane. We'll click on it from here, making sure we click on it. Click on the new sketch. Now we've got the new sketch open. What we can do is just put a bit of angle in here so I can get to this circle here. And we're going to use the import geometry tool. Come in and we're going to import that circle like so. So we've imported that circle. It's gone purple. So we come down, we can see that that ellipse there has been imported in. You can see a little purple dot in the middle. And if we drop this down, you can see normal and external. That ellipse is there. So we've imported that in. And now we can add our circle in here. I'm just going to use the section view so I can see in there. I'm going to come in and I'm going to come up and create the circle. We're going to auto constrain it to the center and bring this out. And what we're going to do is just hover over that circle until I get the tangent constraint. So you can see that I've got a tangent constraint that's come up. Just click and that's now set in the correct position there. So as simple as that, we've now got our circle in there. We'll come up, hit close and go back to our model. And now we can use that sketch and use a pocket and do through all, and we've got the hole that goes running all the way through that. If we click on symmetry to plane, it will use the other side as well, so it will pass all the way through that, so through one and through the other. Hit OK, and now we've got the hole in there. We can hide that datum plane once again. So we've basically created the piston head from that master sketch. So I'm going to rename that body to piston head. Piston head body. Control S to save it, and we've created our piston head. In the next video we'll finish the model of both the piston, the connecting rod and the crankshaft, again utilising that master sketch to position and to model our parts. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.